What's up, guys? It's Long again. It's been a while, but I've been working on a new project. I got into sim racing, and I really wanted to have an active pedal, but the problem was all the active pedals out there don't fit in my current space. My current space is limited to only 285 millimeters, and if you look at the current active pedal designs out there, the Sinew Cube is 415 millimeters long, and the Moza is 382 millimeters long. So born out of desire and necessity, I've made this design, which is based off of ZZY's design, which is called the Foldback. His design also based off of Cold's design, which is called the Stack. So this is my version of the Foldback. And it works. It's working great. And so the way it works is it's got this load cell here, and it measures how much you push on the pedal, and then from that it moves the pedal back the appropriate amount to simulate as if it were a real pedal. And so I've already got it on here, and so I'm trying to push it here. I've got it set to 35 kilos, so it's kind of hard to push right now, but as you can see, I push it and it moves backwards like that. And so you can use this to simulate ABS, road rumble, impacts, all kinds of stuff. It's just amazing. And how I was able to make this so compact is because normally this linear actuator and the servo, which is back here, are usually end to end. And so it makes the pedal super long. But in this version, what I've done, inspired by the two people from before that I mentioned, is that it runs on two pulleys and a belt. There's two pulleys, one down there, and then I've got a tensioner here, which allows me to tension the belt. And so because it is up and down like this, it takes up way less space. And so I got it to fit. This fits in my space with plenty of room to spare, being 2 millimeters under 285, so 283 millimeters long. So yep, this is it. Pretty excited that it works. I've got it with a metal base plate here. This is mild steel, 6.3 millimeters to mount from. And then everything else is pretty much plastic, besides like all the working parts, of course. So you've got the pulley. Let me see if I can get a better view down here. There's the pulleys down there, and you can see the belt. It's a 10 millimeter belt with 3 millimeter teeth. And then over here, I've got, this is all run by a PCB developed by Gil Filbert. This is the V2 PCBA. And so that's the control board. And most of all the software and the stuff behind the scenes comes from, if you go to the DIY Force Feedback Discord group, there's a bunch of guys on there, mainly Captain Chris, Gil Filbert, and TCRF SCHCRW. I'm not sure how you're supposed to say that, but those guys do an amazing job. They've written the software, which is basically a plugin in SimHub, and allows this all to work basically seamlessly. All I've done is make a mechanical design, and they do all kinds of stuff with the software in the background, which makes it just work. It's fantastic. So here's the inner workings of the pedal. You've got here a servo, and then you've got here the linear actuator, which is basically a screw that's turned by this. And so the load cell's here, and when the pedal is depressed, the load cell senses the amount of pressure, and the control board sends a signal to turn this back the corresponding amount of pressure that you're putting on here. And then it returns when you release it. And so this pedal actually has quite a bit of travel. It has about 69 millimeters of travel that you can use. I use about 30 millimeters of it, and then I use that to move the pedal forward or back, like the starting range where I like it. I like it to be kind of like right around here, and then go to like right around there. Or so. But we've got the 2 pulleys here, and then I've got a tensioner which pulls to the side panel on the other side, and then there's a piece right here where the tensioner bolts into. There's some slots in this motor mount right here, and so there's some M6 bolts that this rides on to hold everything, hold the tensioner in place. And then here the servo really doesn't like to have a lot of upward pressure on it, and so what I've made here is I guess a shaft support or a double shear. I don't know if that's the correct term, but it mounts and holds the end of this shaft in place to prevent it from being pulled up too much with the tension. So anyways, that's my pedal. Hope I piqued your interest. I'll put some links in the notes.